Here we come. We are going to do some more U substitution today. We're going to involve our exponential and logarithmic rules. Okay, so you'll notice that your book assignment is going to come from two different pages. One page to practice the natural log antiderivatives with U substitution, one page to work on your e to the x. Okay. So go ahead and also write down our first example. Okay. All right. X over x squared plus 1. What are some things that you notice? Or what is something that you notice? Notice anything. There's a variable in the numerator and denominator that makes it not simple anymore. Oh, is it a composition? What? But x over x squared plus 1 is not. Okay, if we have addition or subtraction in our denominator, we can't break it up. Okay, so Henry thinks this is a composition, probably a good assumption since we're talking about U substitution, right? But I think he genuinely made that observation. I also notice, and maybe you notice this too, that our denominator is a quadratic and our numerator is linear. That's a nice relationship, isn't it? Because we could let U equal x squared plus 1, that denominator. Du would then be 2x dx. And look at this. We have x dx in so we are going to rewrite this as x dx gets replaced with 1/2 du. We want x dx. Okay. And then that would leave 1 over u. Okay. X dx got replaced. There is not nothing left in our numerator. We can write 1. Okay. It is not a 0. So we have 1 over u du, which is nice, right? Because this is why I gave you that joke to be in class. The antiderivative for 1 over u is our natural log rule. Well, I don't want you to confuse my L with a 1. Maybe I should just always do cursive. What? You don't know how to read cursive? Okay. Oh, yeah. Yeah. My first grader taught himself how to write cursive. It's really cursive. Like, I think there's cursive like in one of his writing books, and so he's just like figured out how to do all the letters. Oh yeah. Like quasi. Yeah. Mhm. Right. I think they teach it in 3rd grade and then. Yeah. Okay. Besides my cursive versus non-cursive L's, are we okay with this problem? You know what I like about today? Are we learning anything new? No, we're really not. All right, let's talk about this problem. Go ahead and write it down. Now before, when we had any sort of trig in our antiderivative, then, or in our integral, I should say, then if it wasn't a straightforward rule, I said your only other option is to start using trig identities until you get something that's a straightforward rule. Okay, that's still going to be the case sometimes, but now we have U substitution to help us. Okay, do you notice a relationship between the numerator and the denominator? The derivative of the denominator is the numerator, and that's an important thing to be able to pick out. Because that's the case, we can let U equal our denominator, because then du is secant squared x dx, which is exactly what we have right there. Okay. Our integral becomes, oh, this is really nice. I don't even have to worry about a pesky coefficient. 1 over u du. We get the natural log of the absolute value of u plus c, which would be the natural log of the absolute value of the tangent of x. What? We all have our strengths and weaknesses, Austin, but don't beat yourself up about them. Use your weaknesses to grow. All right, now I do want to talk about something. If this were on the quiz, you would get points taken off if you did not include the absolute value. However, on this problem right here, you would not. Why? Okay, the absolute value around x squared plus 1 is a little bit redundant. So it is not necessary to have the absolute value because x squared plus 1 is always positive. However, I'm fine with it, but you might notice like the answer in Calc Chat probably wouldn't include it. Okay, and that would be why. However, the tangent has a range of all real numbers, so we would have to make sure that it got included there. Okay, here's our next example. I want you to write it down and brainstorm with your pod. Don't actually do anything, just brainstorm with your pod.
Whatever x. 1. So be 1 over. What's the derivative? So u is that right? U is 1 over x dx. Yeah, so that's
You do math.
it's g. 1 over, so it's going to be 1 over. I agree. I don't know. I like short out. Sorry.
Okay.
I think it basically
First of all, we've got a lot going on. I mean, not a lot, but a couple things going on. If you're trying to do any sort of rewriting, yeah, the x could come upstairs as an x to the -1, but the natural log really complicates everything. Okay, now, you all know that 1 over x and natural log of x have some sort of relationship. As I was walking around, it took us a little bit to figure out which relationship we needed to go with, right? Okay, so what should u equal? The natural log of x, because then du is the 1 over x dx. And it looks kind of weird, but this is 1 over x dx. Thank you, show choir, for my Kit Kat. That's who it was from.
I mean, at least you eat it correctly.
How do people eat it?
They don't break it. They just
What? That sounds messy.
This is what I'm saying. She's crazy.
We all have
It's kind of fun to deconstruct the food.
special qualities. I'm not saying like this makes you unique. She's just a unique individual, and you have other things that make you unique.
I have moderation. She does not.
I like it. They think you need to get out.
So wild. And that's the point, because I'm ready to last one.
Be kind.
I guess.
You know what? And some of us eat super fast and we don't get the enjoyment that Kylie does. Okay. So our integral becomes 1 over u du. This is going to be fun because we get the natural log of the absolute value of u plus c. But what is u? We have the natural log of the absolute value of the natural log of x plus c. Isn't that fun?
Isn't the x have to be the absolute values?
No, because of this right here.
So the x is not inside of that.
The 1 over x dx gets replaced with du. Right, which is u. So I wrote 1 over u. Yeah. What did you, what do you? Okay. I mean, I wouldn't. Okay. Important example alert. Important example alert. I'm full of tricks. This is what Kylie said.
You don't have to use Euclid, right?
I don't want to take the words out of your mouth. Yes, okay.
No, wait, it's gotta be like.
I knew exactly what she was saying. I was just hoping she could get the word. Okay, we don't have a rule for tangent for an antiderivative. Did you notice that? We don't. Well, what? Well, this is how we get our rule. Kylie said, which translated to, we can write it as a fraction, sine x over cosine x dx. Awesome, because those two have a pretty great relationship with each other in calculus class. Do you think they're best friends, or do you think that they? I feel like they're like friends, but they're competitors. You know what I mean? Are you okay? No, I'm talking to Connor. He's like shaking his desk. Are you okay? Okay. We can let u equal our denominator. Now here's where we need to be very careful when we're doing u substitution, and sine and cosine are a part of it. We have to think very carefully about derivative versus antiderivative. Right now we're doing a derivative. What's the derivative of cosine? I'll be sure to let Coach H know. We have negative integral of 1 over u. Are we okay with what I just wrote? You guess. This class got smaller, but noisier. Ava left. Yeah. I know, but how are we like?
Did you know that Ava and I share a birthday?
I did
We were in the
not.
same class in 5th grade, and we tried to figure out how we're gonna do that.
Because you. Okay, so we have negative the natural log of the absolute value of cosine of x plus c. You can either remember that, or you can remember to do u substitution to get it. Okay, in your homework, I think in your homework, if not, we'll do it as a warm-up tomorrow. You'll do cotangent. If you were to just guess, what do you think the antiderivative for cotangent is? Positive natural log of the absolute value of sine of x plus c. Okay, so let's talk about the rules that we have. Our antiderivative rules. We know the antiderivative of a constant. We know the antiderivative of x to a power. We have 6 trig ones. E to the x, 1 over x for the natural log, and now we have tangent and cotangent. Okay. That's 12. We kind of combined the second and third one into the power rule. Wait. Tell me the first one.
Oh, the orange.
Yeah.
Are these like the same?
I mean,
ones? The
so
second and
like
third?
these two can kind of be grouped together.
Oh, okay.
Yeah. Okay. All right, let's do this one. I'm very excited about this one. Very excited. Write this down. Write it down. Can we use a straightforward rule on this one? No, not at all.
Wait, maybe you can factor. Is it factor?
I would think that x minus 2 is not going to be a factor of our numerator because our last term is -3.
Well,
But what kind of fraction are we dealing with? The one where the numerator is bigger than the denominator, which means what is possible? We can divide. We can actually take 2x squared plus 7x minus 3 and what? And divide it by you did it in pre-calculus. You also did it in algebra 2.
isn't there more simple where you just like use numbers? But just like,
Guys, I mean, that's a possibility too. X times what is 2x squared?
2x.
Thank you. Then we take x minus 2 times that number. And we are going to subtract those numbers. That's why we pay attention. Why? Nope. Okay. So x times what is 11x? 11. So then we take 11 times this divisor. And we subtract. What's our remainder? Okay. That's what we're going to do. Our integral can become 2x plus 11 plus 19 over x minus 2. We actually performed the division. So this expression basically just simplifies to this expression. And now we have a much nicer antiderivative to complete. The antiderivative of 2x is x squared, 11, 11x. 19 over x minus 2 is 19 natural log of the absolute value of x minus 2. Let's see. Great. If you have an improper fraction, you can perform the division. Mind blowing? I know. A long division. I think Kylie misses the polynomials chapter. Just that part? Okay. Okay. All right, let's change gears a little bit here. Okay. We throw in some e to the x. Now, you're going to have situations where rewriting it is going to be enough to be able to help you use basic rules. Sometimes there's going to be an option. I could rewrite or I could try use substitution. Do we have a composition? Yes. And remember, e to the x has a derivative of e to the x. So we could totally let u equal the e to the x plus 1 that is inside that square. because then du is e to the x dx, which is totally in our integral. So we have 1/3 u cubed plus c, or 1/3 e to the x plus 1, the quantity cubed plus c. That was the last example that we're going to do as a class. Okay. I have a small piece of paper that I'm going to give you. Every small piece of paper involves an integral. Okay. You are going to take this and perform the antiderivative, whether on this piece of paper or in your notes, I don't care. Okay. I have a variety of problems, so you and your neighbor are not going to have the same problem. But if you would like to phone a friend and ask your neighbor, that is totally fine. Do you even understand the phone a friend reference? Who Wants to Be a Millionaire? Oh, the taxi show.
Oh,